Thank you, Eric. Everyone, welcome. I'm excited to be here with you today. We are going to spend the next hour to an hour and a half talking about building a hybrid environment in VMware Cloud on AWS. As was mentioned, my name is Brian Graff, and I'm a Senior Partner Solutions Architect at AWS. So let's go ahead and jump right in. So at the end of this, I want you to be able to know a few things about VMware Cloud on AWS, as well as integrations with native AWS services. So we'll walk through some of the basic network and connectivity. We'll talk some foundational points of VMware Cloud on AWS, so that if this is your first time hearing about this, we'll all be on the same page in terms of what we have and how this works. We'll talk the network and connectivity, how this works between the VMware side of things and the AWS side of things, and how we can enhance our applications easily, what that means, as well as modernizing or integrating additional AWS services with the virtual machines in VMware Cloud on AWS. After we get through all of that, we'll move over into transitioned into some live demos. Well, I recorded them just in case and to speed things up because some of them take a bit of time. But we'll go through a number of demos until we run out of time. So that being said, let's get a foundation of what VMware Cloud on AWS is. So on this left-hand side, what you see is traditionally what people currently have, the on-prem data center. This is the VMware environment where the customers really are in charge of everything, right? For the entire stack from the ground floor up. This means that they're in charge of the servers, the power, the cooling, the networking, the storage, updating VMware, the vSphere environment, the virtual machines themselves. The entire stack is being run and maintained generally by the customer. On the right-hand side, well, we'll come back to that. On the right-hand side, we have AWS. And this is what you see traditionally when you log into AWS and go into the console. You have access to all of the AWS services there. What we're going to focus on is the VMware Cloud on AWS aspect, which is right in the middle of both the on-prem data center and the AWS services. And as you can see here, this is being run on Amazon's global infrastructure. This means that you no longer have to worry about your data center being in a single location. You have the ability to spin up VMware Cloud on AWS in any of 17 of our regions right now around the world. That means that your applications and workloads can be closer to the end user, the consumer, and give them that better experience, right? What you'll see here is this arrow between both vCenter servers, on-prem and in the cloud. Now, this is important if you're running a hybrid environment. All right, we'll talk a lot about what's going on between VMware Cloud and AWS and everything on the right side with the native AWS services. But for those customers that choose to have a hybrid environment with an on-prem environment still connected with VMware Cloud on AWS, you can leverage our technologies to be able to see both vCenters in the same vSphere console. And so what's really important about this is for customers who are interested in moving to the cloud, but are not ready to migrate everything to a new technology, right? And that includes things like changing your monitoring, changing your backup and DR solutions, updating all of your scripts, your SRE runbooks. All of those things are considerations that have to take place if you're migrating into a new technology or new cloud. However, with VMware Cloud on AWS, because the virtual machines are basically relocating to another VMware platform, you can maintain your vRealize suite. You can use Power CLI. You can use the same APIs and CLIs that you used on-prem. And so it's very beneficial to customers to be able to continue having that operational consistency. But as I said, this is about creating hybrid applications. So for the next hour or so, we'll focus on everything in the middle and to the right with native AWS services. So before we move on, I want you to take some time during the session and kind of remove this idea of how things were done traditionally. Okay, everything has to be in vSphere. How would I add things into a vSphere environment? I want you to start to think as we go through the different demos and we go through the different scenarios, how can I start mixing and matching different AWS services with my workloads that are running as virtual machines? How can I do this mix and match? And I think that by the end of this, between the demos that we have and ideas that you come up with yourself, I think you'll have a really good understanding of some of the potential that you have with VMware Cloud and building hybrid environments. So kind of the basis of this, right? We have to understand a few things about the networking connectivity, because that is the foundation of how these two technologies will communicate with each other. Throughout this, we'll talk about the ENIs. I'll reference ENI quite a bit. And the ENI is an elastic network interface within AWS. And it's basically a virtual network card that you'll see each of the hosts have. And the VPC is going to have this ENIs located inside of the environment. So we'll talk about what those are a little bit now and a little bit going forward. But each ENI has a private IP in the range of the subnet of your VPC. So from the AWS side, if you're new to AWS, a VPC is your virtual private cloud. It's kind of the foundational network cube that you're going to have all of your applications and services running in. This is traditionally an ENI can be owned by you or managed by an AWS service. And you can apply the security groups to them. So essentially create firewall rules for each of the different ENIs. So why is this important? This is important because when you deploy VMware Cloud on AWS, it deploys into a VMware-owned VPC or AWS account, but it attaches to your own VPC in your own account. And that connectivity, that communication channel goes across an ENI. So within VMware Cloud on AWS, we have our virtualized networking, which uses NSX. And there's what's called a T0 router. All traffic is going to traverse this T0 router. And for all intents and purposes of this session, any traffic that goes between your own AWS account and VMware Cloud on AWS is going to traverse this T0 router. This is important because every single host in VMware Cloud on AWS is going to be attached to an ENI in your own account. All right, but only one of them is active. And the one that is active at any given time is the ENI that is attached to the host that the T0 router is currently running on. Okay, I'll say that again. So the only ENI that is active at any given time is the ENI attached to the vSphere host where the T0 is actually running. And now what will happen between VMware Cloud on AWS and your attached AWS account is anytime a new segment or a new network is created within VMware Cloud on AWS, it will actually also update the route table within your AWS account so that applications and services running in that customer-owned VPC can communicate with virtual machines running in VMC. Well, what happens here is if, for example, there's a host failure or a host is migrated out and a new one is added in, that T0 router is going to end up on another host. So VMC is going to go ahead and see that it will have the ENI change to a new active ENI that's attached to the host that the T0 is then running on at that point. And it will also update the route table in the customer VPC to make sure that traffic continues to flow into VMC as it should. So this is important to understand. There's a number of different ENIs here. The ones that are put in here are added, created, and updated by VMC when you deploy the SDDC. So there's no work that has to be done in terms of communication here. So we've talked about kind of the connectivity between the two. Let's talk about AWS endpoints for a minute. There's several different types of endpoints, and these endpoints will impact how your different services communicate within AWS. So there's a VPC endpoint. Let me go back. There's a VPC endpoint and endpoint interface endpoints as well. So a VPC gateway endpoint, there so far are two for S3 and DynamoDB. Now, what this will do is, generally speaking, if you have an application or resource within a VPC trying to reach S3, it's going to go out through the internet gateway. Okay. If you leverage the gateway endpoint, what will happen is a gateway endpoint will be deployed into the VPC, and there will be an additional route added into the route table, which basically points traffic that's going to S3 to use this VPC endpoint instead. Okay. So this is really only useful in terms of VMware Cloud on AWS with S3 if you choose to do it this way. Now, there's another way though, and that is using an interface endpoint, which is powered by Private Link. So what is that? Interface endpoints are being created at a fairly rapid pace. You're going to start seeing them with more and more services as time goes by. And as you can see from this screenshot, when you go to create an endpoint within AWS, you can see that there's a handful of interface endpoints that already exist. Okay, now these can be used by a number of different services. And what this does is it allows you to create connectivity from within your own VPC, essentially directly to a service. Now, there's 3 different ways that Private Link will work. The first is with a consumer to provider connectivity. Now, this is what we use with VMware Cloud on AWS. You have a consumer VPC, you have a provider that has a service in it, and it allows the consumer to connect to that and leverage the services within that VPC. The other one that you'll use is with AWS services and service endpoints. What this essentially will do is it will drop an endpoint into your subnets that you choose, and basically have direct access to those services as if they were in your VPC. And then the third one that we're not going to talk about here is leveraging Private Link with AWS Marketplace. So what does Private Link look like? Okay, so if we take a look here at traditionally at the EC2 APIs, right, at the API endpoint, DNS is going to resolve a public IP for that and communicate out to the endpoint. With Private Link, if you deploy Private Link endpoints into each of your availability zones, they will each have an IP address within that subnet. Okay, so for example, in this top one, you can see that the subnet for AZA is 10.10.1.0/24. And you'll see that it's given a private IP address within that network range. What this allows to do is when you send traffic to the EC2 endpoint, it's going to leverage that ENI, and it will also give you multiple different endpoint DNS addresses. It will give you one for the region, but it will also give you one specific to an availability zone. So you can choose with your applications where you want to point this to. You can point it to the EC2 API endpoint for the region, or if you want to keep everything within a specific availability zone, you can start to leverage the DNS for the each of the availability zones. Now, if you keep everything within a single availability zone, you don't incur any sort of cross AZ data charges. So that is one of the benefits to using Private Link with a specific subnet or availability zone. Okay. One of the last things that we'll talk about here in terms of networking is what the actual networking, logical networking looks like within VMware Cloud on AWS. So as you can see here on the left-hand side, you have the customer-owned account. And on the right-hand side, you have the VMware account that is running your VMware Cloud on AWS SDDC. Now, within the SDDC, there's 2 different network overlays. Okay, the first is the management network, and that one has everything that is used to run the SDDC. So your vCenter server, your NSX appliances. If you choose to deploy HCX, it's going to have your HCX appliance and any of the other appliances that are deployed to run HCX. Same for DR. So anything that is used to manage and run the SDDC is going to be in its own management network. And there's certain restrictions around that and the type of connectivity that you can have into that. And part of that too is the permissions. So it's made so that the consumer or the customer can't go in and mess something up in the management network or within the management appliances. That then connects to the T0. And we talked about how the T0 router, all the traffic will run through that. We also have the compute network overlay. And inside the compute network overlay is where all of the customers' VMs are going to run. Regardless of how many networks segments you create, they will all be running within the compute network overlay. And those will also then connect into the T0 router and out to either the internet gateway or over to the customer AWS account. So if we look at this example here, we can see we have two different network segments, a 192.168.1.0 and a 2.0. Both of these are in the compute network overlay, and this is created by the admins of the SDDC. So you can create the different network segments here for your virtual machines to run in. You can do all of your firewalling, your microsegmentation, basically all control over your virtual machines are done in this side. And you can see that the T0 is connected to an ENI in the customer account. And in this picture, you can see traffic can go to S3 or to EC2 instances. And we'll talk more about that in a few slides. But hopefully this has given you a pretty good understanding of how the connectivity works at a higher level, at least, between the SDDC itself and the customer account. So a few considerations when building your hybrid applications. These are a few things that will keep you from hitting roadblocks. The first one is deploy those resources in the same availability zone as the SDDC. So when you deploy a VMware Cloud on AWS SDDC, you can choose which VPC that this is connected to and an availability zone. Now, making sure that you're using the same AZ, like I said earlier, will keep you from incurring cross-AZ data charges. Now, it's up to you to decide how you want to build things out kind of on the AWS native services side if you do integrations here. For example, if you have additional high availability or an active passive environment that you're connecting to within AWS, you'll want to take this into consideration in terms of, do I use the same AZ for my primary or my active, or do I use a different one, and so on and so forth, right? These are just some topics to consider as you're looking at this. Using private link, okay, keeps things secure and private, using the private IP range of the subnet. Additional AWS services are billed to the account that's connected to the VPC. So one of the things that I'm not going to focus on here, but we'll briefly discuss, is that when you deploy your VMware Cloud on AWS environment, okay, all of that is grouped up as a single bill. Any additional things that you connect to it, you'll see that comes through your own account that the AWS services are running in. So keep in mind that your SDDC won't have all the charges for your services, and vice versa. If you're creating a hybrid environment, you'll have those billed on the same account as the other services that you're running. And then the key here, once this final bullet point is understood, everything else just works. Okay, both the AWS security groups for the VPC and the NSX firewall rules need to allow traffic between each other for us to be able to do any sort of hybrid environment. Okay, so think of this as a bridge with gates on both sides, right? On one side, you have VMware Cloud on AWS. One side, you have AWS services. Now, if I open traffic on one side, on the NSX side, right, my traffic can flow in and out of your SDDC. But unless we open the security groups on the AWS side, it doesn't really matter, right? So we need to make sure that we open those. Now, best practices is going to be to only allow specific traffic that you need across between the two sides. In these demos, you'll see that I just use any and all traffic. This is not a production environment, so keep that in mind. And you'll see kind of how we do some of that networking here in just a minute. So let's talk about enhancing current applications with AWS services. Now, like we talked about at the beginning, a lot of customers use VMware Cloud on AWS to move quickly to the cloud and be able to take advantage of certain cloud technologies and functionality and to get out of their own data centers. Okay, these customers may not be ready to do any sort of big modernization, and that's okay. The question then is, how can we start to enhance those applications without actually really modernizing them with as little change to the application itself as possible, right? Is that even possible, right? So let's take a look at this. What are some of the quick wins and low-hanging fruits that I could potentially use, or you could potentially use, when you migrate workloads to VMware Cloud on AWS? Okay. Questions to ask yourself. What AWS services can I easily attach to an existing application with very little reconfiguration that will enhance the end user's experience? And what additional business requirements can be met with native AWS services? So what I mean by this second question here is, traditionally in an on-prem environment where the customer is in control of everything, there may be certain technologies that are not used, or certain technologies that you don't have room to even try to use in an on-prem environment that you could now use in the cloud. So some of this could be additional data analytics. Maybe it's data warehousing. Maybe it's any sort of business intelligence that you can now attach because it's running as a service next to the application. So keep that in mind as we go through this. So one of the first ones that is probably the simplest enhancement that you can do to an application running in VMware Cloud on AWS is adding an application load balancer. And once we add an application load balancer, we can actually do a couple of additional things to improve security and uptime for our applications. So although the virtual machines, if we deploy a regular SDDC, even though those are going to deploy into a single availability zone, what if I want to have a load balancer as a service? Well, it's pretty simple. And as you can see from this diagram, it's pretty straightforward. On the right-hand side, we have our customer AWS account, and in there we deploy the application load balancer. That application load balancer would be in a public subnet or public subnets. And then we can create a target group that targets the IP addresses of the virtual machines that are running in the other SDDC or in the other VPC. We'll do this. We'll walk through this one in one of my recorded demos at the end. But what you'll see is that you have the ability within an application load balancer to choose either instances or IP addresses or Lambda functions. In this case, we choose IP addresses because the virtual machines aren't actually running as an instance within the account. So when you choose the IP address as the target, you can then choose another private IP address that is not within the default range of the VPC that the application load balancer is running in. I know that may sound confusing now. We'll walk through this and it'll all make sense in the demo. But we can then take the private IP addresses of those virtual machines and attach them to the target group. Now, one of the other things that we can do, if we want to take this even a step further, is let's say that we have our virtual machines running, let's say that they're web front ends, and they're running in VMware Cloud on AWS. Let's say that I wanted additional availability of these. So maybe I deploy the same web front ends as EC2 instances in 2 additional availability zones in my own account. I can create a target group that includes all of these, and I'll show you that as well in the demo. And that way we can continue to have even higher availability, all fronted by an application load balancer. So there's really no code changes that have to take place here, but all of a sudden I've got my load balancing set up for me, and I can take this to another level and use a web application firewall or Shield, right? So I can start using additional services that tie into the application load balancer that help with DDoS attacks or malicious types of attacks on those web servers. And there's really no code changes at all here. We're just repointing the traffic. So that is what I mean by enhancing an application. So you'll see that here. We can then add in things like Web Application Firewall and Shield Advanced. So adding Elasticache for Redis is another one that I have a very, very short demo of that I'll show in a few minutes. Now, what does this do for me? Well, for example, I have Magento running as a virtual machine. Now, Magento is an e-commerce platform, and it would be really nice if I had an in-memory data store for caching some of this content that is being served up to my users. Now, it's possible that on-prem, I didn't have a Redis cluster that I managed or maintained or configured or even had at my disposal for my virtual machines. So now that we're in VMware Cloud on AWS and looking through the AWS services, I can say, what here can I use? This goes back to that second question that I had. What can I use to enhance business requirements that I or my customers may have? Now, in this case, leveraging something like Elasticache for Redis will give us the ability to speed up those queries or those results for our end user. Now, in terms of how much effort this takes, is basically deploying the cluster in Redis or in Elasticache in your own AWS VPC, and then pointing Magento in the virtual machine to use the IP address for that cluster. And you'll see that in the demo. So it basically took one small change within the application, but now I have all this added benefit. And I don't have to be the one to maintain and manage the Redis cluster, right? So once again, I'm going to ask that question. What can you be doing in your own environment, if it's in VMware Cloud on AWS, to enhance an application without technically having to modernize that application? How can I get those low-hanging fruits or those quick wins that benefit my customers? So just like I was saying, we add our Elasticache cluster. We have to make sure that that traffic is enabled both in the security group and the NSX firewall. We'll point the application to the cluster, and then they're on their way. So what if we want to take this a little bit further? Maybe we want to move certain portions of our environment to AWS services. We're not talking a full-on modernization here, but let's say that we have certain business requirements that are more easily satisfied within AWS. So 2 questions to ask ourselves. Which AWS services are required to achieve that desired business outcome? Okay, so similar to the second question of the last slide that I showed you with these. And the second is, what can I do now using AWS services that were impossible or very unlikely to achieve in my on-prem environment? Okay, so for example, let's talk about using a multi-AZ database with read replicas. Now, I may have my database migrated up or relocated up to VMware Cloud on AWS. But as an admin, you have a lot of work to create those replicas or to create an active passive environment in VMC. And keep in mind too, this is all within a single availability zone unless you deploy a stretched cluster. So if there are business requirements that say, hey, I want to have an active passive environment with a passive database running in a different availability zone, and I also want to add read replicas so that if I do business queries on the data, I'm not impacting the performance of my primary database. Or I can say, hey, maybe I want to split my traffic up and I want to send only my writes to the primary database and all of my reads to the read replica. Then I can fine tune my database and my instance type to, be as agile and performant as possible, without taking additional overhead for things like the read queries that you might not need. And the read queries could be on a smaller instance type. So it doesn't have to be the same size as the primary database. But at that point, maybe I can start leveraging these other AWS services like QuickSight, like Redshift, like, we've got a number of different applications out there that we can then pull our data from in here and add it to a data warehouse and run queries on them that would have been probably impossible, or at least take a lot of time and effort to create and architect in an on-prem environment. Now, the change here is obviously less of a low-hanging fruit because I have to migrate my data into RDS. But if I migrate my data into RDS, I have all these additional capabilities and things that allow me to keep the best of both worlds. I can still keep my application and web front end running in VMware on VMware Cloud on AWS, but I can also get the additional availability and performance and these additional functionalities that I wouldn't have had on-prem by leveraging the RDS environment. So what would one of these look like if I wanted to do data warehousing now, but I still want to run my virtual machines in VMware Cloud on AWS? I want to keep that same operational consistency. I want to be able to use the same APIs and scripts and runbooks that I've had and use on-prem. How would I integrate and start doing big data or data warehousing? So what this might look like for you is you've got your virtual machines running in VMC on the left-hand side. You can then deploy things like Amazon's database migration service, and also known as DMS. And DMS can replicate data from a database running as a virtual machine in VMC. Okay, there's no problems there as long as we allow the networking to allow the traffic on both sides. So if I allow that traffic on both sides, DMS can then replicate data and change data from the databases up into S3 as well as EMR. Now, maybe you're running Apache Spark, maybe you're running Hadoop, and you're doing big data queries and analytics using EMR. You can then also dump those results into S3, as well as then leverage the Redshift service for your data warehousing and do SQL queries off of that. And potentially even more. We could add in QuickSight onto that as well. And we can mix and match a whole lot of other AWS services here. And all this is possible now, right? Because we moved our virtual machines up into VMC. If you look at this and think, how would I architect this in an on-prem environment? It would be probably pretty overwhelming. But it brings it to another level of simplicity by allowing your virtual machines to run right next to those AWS services. Okay, so once again, it says live demos, and I apologize. I had originally intended to do these live, and as I was doing them prior to this, I decided that it would make more sense for me to speed them up as we deploy certain services that can take a handful of minutes to deploy. I wanted to make sure that we kept your attention. And so that being said, I did record these. And I'm going to pull those up right now for us to use. If we can cue demo number 1. All right, we're going to pause this for just a second. Let me see it bigger. All right, so for the first demo, we talked about VMware Cloud on AWS enhancing an application with using application load balancers and WAF and Shield. What we're going to run through here is how you could use AWS services that are tied directly to VMware Cloud on AWS before doing the application load balancer. And then we'll walk through those. So as you can see in my environment here, I have 3 different web front ends, VM ALB 01, 02, and 03. I'm going to take the first one and I'm going to get the private IP address of that. And I'm going to go to my VMware Cloud on AWS account. Now here you can see all the networking for VMC. And I can request a public IP. Now this is using AWS in the backend and grabbing an elastic IP for consumption within VMC. So you can see a public IP address was created, and I'll go and create a NAT rule that allows traffic to go from that public IP to the private IP address of this first virtual machine. Now, keep in mind that unless I'm using a VM load balancer, this is only going to work for a single web front end that I've got. Now, I've created the NAT, I've got my public IP. Now I need to create a firewall rule that will allow the traffic to actually come into this virtual machine. So under Gateway Firewall, I can come in here and give it a name. And in this case, we'll give it the same name as what we've been using here, the ALB01. And then the source is any, right? This is coming from the internet. And the destination, I'm going to choose specifically this virtual machine. Now we can go in and add a group later that says, hey, we can use the same firewall rule for all of my ALB virtual machines, or I can use the same firewall for everything on the same network segment. But in this case here, we'll set the member to virtual machine and we'll select ALB01. So we can come in here, click on virtual machines and choose ALB01 and apply. Now, the last thing we have to do is publish this. I guess I'm jumping ahead of myself here. We'll select just the HTTP service so that we're not allowing all traffic through to this virtual machine. Now, once I select my HTTP service, I can publish this and we're good to go. So I can go back to my public IP and grab that public IP address and we'll try and resolve that here. And you'll see that we hit my web front end and it gives us the private IP, the public IP, and who is resolving that. Okay, so that's how we do it within VMware Cloud on AWS. But like I said, we want to have hybrid services. We want to integrate with AWS services. So we'll go back into our firewall settings and we want to allow traffic to flow inbound and outbound between VMware Cloud on AWS and VPCs. So in this case, we have our VPC inbound rule and we want to select all of the connected VPC prefixes. So that is basically taking the subnets of the connected VPC and adding that in here as a group. We'll then go ahead and create a VPC outbound rule, which the source will be anything within our account, and the destination will then be the connected VPC prefixes. And as I said before, I'm allowing all traffic through, but best practices in a prod environment would be to only allow the services that are being used. We've published this, and now we need to go in and create our application load balancer. So if we come into EC2, we can go to our application load balancer or our load balancers here and create an ALB, application load balancer. And it's the same way that you would do this with regular AWS services. We give it a name. This one is internet facing. This is using just HTTP. And we'll select where we want the load balancer to deploy. So we choose both AZs, and we need these in the public subnet, even though our applications are running in the private subnet. And that is so that it can have connectivity out. This screen was because we didn't use HTTPS, and now we'll select our security groups, which will use our pre-created VMC integrations ALB security group. And we'll create the target group. Now, this is for the 3 virtual machines. So we'll call this VMC integrations ALB and or Q3 workshop. And like I said, you can choose instances, IP addresses, or Lambda functions. So we'll take the IP address and then we'll need to grab the 3 different private IP addresses. We'll choose other private IP address because it's not part of the 10.0 network. And we'll go back and forth and grab these different IP addresses one at a time, and we'll place them into this target group. So we've got our ALB1, ALB2. We'll grab that IP address here, and then we'll paste that in, add it to the list, and then grab the last one, ALB3. So we now have our 3 private IP addresses that are in VMware Cloud on AWS, and this ALB is in my own AWS account. So it creates everything, and we can go check on that now. And if we go to our listeners to see the health status once this provisions, we will actually see, and I sped this up. This normally takes about 10 minutes. We'll go to our listeners here, and we'll see our 3 virtual machines. And if we take a look, oops, all right, all 3 are unhealthy. Why is that? Okay, if you recall, we set up the firewall rules in VMware Cloud on AWS, but we didn't actually add the security group for the application load balancer into the default security group that we need to be able to enable connectivity between the AWS side and VMC. So here we'll create an HTTP security group rule, and we'll add in the security group for the application load balancer. We'll clear out one of the old rules that I had there and save that. Now that we've connected or set the connectivity on both sides, if we go back and take a look at the listeners and we click on the integrations, you'll see all 3 are healthy now. So that means that we have connectivity between our VMware Cloud on AWS side, and our AWS services. So if I click on my application load balancer, I can then go and grab the DNS name and give this a try. And what do we see? All right, we have 1.5, that was ALB1, 1.2, which was ALB2, and 1.3, which is ALB3. So as you can see, as I'm refreshing the screen, we're leveraging that application load balancer now, and it's cycling through our virtual machines, which is pretty cool. So let's take this one step further. So let's go to WAF and Shield and add that web application firewall. We want the additional security for DDoS and exploits. So how does that work? Once again, as you've seen, we haven't made any changes to the underlying applications at all. So this is truly an enhancement that you're getting because you're using VMware Cloud on AWS without actually changing, rescripting, or modernizing the application itself. So we'll go ahead and just grab a couple of rules here. In this case, it doesn't really matter for the demo because it's basically showing you the capabilities that we have here. So we had bot control. I think we had PHP application, and then we'll add WordPress, because who doesn't want to add WordPress application rules to your WAF? So we've got these. If it hits any of those, it'll block the bad actors there, and we can go ahead, click next. Everything here looks good. Click next again. We'll review our rules and we will create our ACL. So all of a sudden, I now have that additional functionality. Now, if I stop this for just a second, in my diagram that I showed of the ALB application, one of the things that I had was EC2 front-end instances running as well. So what you're going to see here, if we look at EC2, I have an ALB instance running ending in 082D. Now, I could have multiple of these in here. I could create an auto scaling group with these as well. But let's go ahead and just add that EC2 instance into my targets. So not only do I have VMs running in VMC, but I'm adding this from another availability zone. So I add this in, I can go ahead and refresh. And when we see that it's healthy, we can try using that application load balancer again. If we refresh this on the left-hand side, you'll see our 10.0.1.143 and all the data about that, because that's what my web front end is bringing back. So we've just added an additional web front end into EC2. It is accompanied by the 3 that are running as virtual machines in VMware Cloud on AWS. It is cycling through all those. We have web application firewall set up, and we can, if we wanted to, use AWS Shield as well on here. So take a second, bring all that in, and in just a matter of minutes, we've enabled the traffic between the two technologies, VMC and AWS services. We've spun up an additional service, the application load balancer, and we've added on all this functionality that is then taken away as a responsibility for managing yourself in an on-prem environment. So Pretty happy about that one. Let me go ahead and share. Let me go ahead and queue up the second demo here. Okay, so this demo that we'll walk through here is adding in that Multiaz database and leveraging deploying an RDS database that a virtual machine is going to leverage with its application. So in this case, we're going to use Suite CRM, and Suite CRM will then install itself from the VMware side onto RDS. And then from there, we'll actually go ahead and make it multi-AZ and add read replicas and so on and so forth. So let's take a quick look at this. So in my account that's connected to VMC, I'll go into my RDS service. And for this demo, I just have it as dev test. The instance identifier will be the same as the database name in this scenario. So Suite CRM, I set my password. I'm just going to use the default instance. But I can set additional settings here, as you can see. This I did not make multi available or multi-AZ available. It's just the main single environment. And this is not publicly accessible. Now, this is key. We'll talk about that again in a few minutes. But this is not available outside of the VPC. Because we have that ENI that we talked about earlier, the VMs that are in a different VPC can still communicate with us, although it cannot be reached from outside of VMC or this VPC. So you can't reach it from the internet. You can't reach it from any other VPC. So while that's deploying, we'll go into our virtual machine here and we'll accept the Suite CRM install checklist. We go through everything here is fine, and we need to select our database. So we already named our database Suite CRM. We'll go into the identifier here, and we need to get the endpoint. Now, this endpoint is what is used with an installer. So the host name in Suite CRM is going to be the RDS endpoint in the other account. So once we add this in, we'll add in the username, which by default here is admin, and the password that I created during deployment. And then so we can continue on, we'll fill out the required fields here, and then we will add demo data, just so you can see that things really did install, that it's working. So we give it the email address, we choose populate with demo data, and then we'll go to next. And this is also sped up a little bit here because it does take it a few minutes to create the database and install all that sample data. You'll see some notices. They're not errors. It's just saying that it did some other tasks along the way. But we can log into Suite CRM now, and we can see the demo data on the right-hand side. So this is all stored in RDS in my connected VPC, and it's not publicly accessible. We're going to go ahead, since I didn't deploy this as multi-AZ in the beginning, we want that additional availability. We're going to create the standby instance here, and everything else, everything else here looks the same. That's all good. So we'll continue and we'll say apply this immediately, and then we'll speed it up. Now, what we've done here is we've not only added an additional RDS instance that is managed for us, but we've created a more highly available instance by having an additional AZ in there. And now I'm creating a read replica that I can use for all of my additional analytics that I want to do, any queries that I want to do. Or like I said before, if I want to split my writes and have my writes go straight to the primary and all my reads go to the read replica, I now have the ability to do this. And it's not taking a whole lot of additional effort, right? Because we're using this managed service. So in a nutshell, we just finished adding in additional capabilities, with really the only change being rehosting that database into RDS. Now, there's plenty of different ways we can do this. We can do this with the database migration service. We can do this with, if it's Postgres, we can do a PG dump, PG restore. There's a number of different ways that you can get that the database data into RDS. And that's something for another time, another topic. And we're happy to create more content around that. But very straightforward, just as you would if you were moving to native AWS. We'll jump to the next demo. And I know we're flying through these. This Elasticache demo here, it is going to be a lot shorter. I realized after I created the demo that I could have spent more time in here, but I also didn't know how much time I'd have with this workshop. So we'll walk through this here. I'm going in and I'm creating my Elasticache cluster. Now, like I said before, my virtual machine, as you can see up in the top left, the second tab that I have in Chrome is my Magento app virtual machine. Okay. It's running just a simple Bitnami version of Magento for purposes of this demo. And that's running in VMware Cloud on AWS. But it supports Redis as a caching function, caching tool. So we'll go ahead and deploy Elasticache into my own VPC. And we'll give it a name. We can choose the node type and the number of replicas. And this is going to be completely dependent on the application and the business requirements that you have. What I'm trying to show here is that that this is possible, and kind of open up in your mindset the art of the possible. What can you do in your own environment to further your requirements or your user experience? So we'll go ahead and select our zones. We want the primary to be in US East 1A, which is the same as our SDDC. The replicas are going to be in both A and B at this point. We have our security group set up. We'll grab our default there and save it. And then we will just go ahead and deploy this. We're not going to make any other changes here. And once that deploys, it's going to give us some endpoint data. So what we'll do is we can then go over to Magento once this finishes creating and copy and paste in this data using a command from the Magento CLI. So here I am inside of my Bitnami Magento virtual machine. And we'll go ahead and start typing out the command here that is used to add a cache. And we'll grab the parameters here. So as you can see here, we want the backend to be Redis, and then we need the actual address for that. So just like we did for RDS, we need to go in and find the actual endpoint's name. So in this case, the primary endpoint that we're going to use is this one here. We'll copy that off, and because this is running in a virtual machine that I'm using through the web console, I can't copy and paste that per se, but I went ahead and paused it and put that in for us. Now I've gone ahead at this point, and if I go back real quick there to the very end, as you can see here, I ran that command with the endpoint address of Redis, and then I overwrote the backend configuration, and it saved. Now, if I wanted to take time and go in and populate my Magento environment, my e-commerce platform, I could do that and show you how it speeds up, right, using this cache. I figured that would take too long, but as you can see here, all the steps we took were making sure that the security groups and firewall rules are in place. We checked that off at the very beginning of these demos. We deployed our Elasticache cluster, and then we went into Magento. And like I said, it's one step more than enhancing an application, because we are technically changing some data within the application. But as you can see here, with essentially one line of code, we've added in this additional functionality that maybe would not have been possible in an on-prem environment. Okay. All right, let's go to the last demo that I have here, which is, let me get this switched over. Okay, so a little background on this one. What we're going to do is take advantage of the AWS directory services. So basically running Active Directory from within AWS. Now this is going to be beneficial if, for example, you already have directory services running with existing AWS content or services, or if you want to tie in your regular Active Directory into directory services and then leverage the directory services DNS endpoints for all of your different virtual machines. So what you'll see here, if we go ahead and start this, we're going to actually just create a new one. Now that's just assuming that our on-prem environment didn't actually have Active Directory to begin with. But if you choose to, you can connect your original Active Directory from VMware Cloud on AWS to directory services. So we'll go ahead and create our directory DNS name. Postgres was auto added in for some reason. That is not part of the demo. And we will create our subnets that we want this to be a part of. And as you can see, we're adding it to the private subnets 1A and 1B. So we'll go ahead and create the directory. This can take up to an hour to deploy. So we've gone ahead and I've cut this down and made it so that it works in about 10 seconds. And once we have our directory, we're going to do a second thing here, which is going to be using FSX, which is a file storage service, and we'll deploy that, which requires the directory service to do. Now, once we deploy FSX, then we can go ahead and start leveraging that as a shared storage backing for our virtual machines. Now, why is this important, or why would I want to do this? Okay, so there's probably a number of different reasons why we'd want to do this. One being that I want to, run this multi-AZ. Maybe I want to have additional availability for my data, or maybe I just do a single AZ. Maybe I want to offload some of the data from VMware Cloud on AWS, some data that maybe doesn't require the NVMe local storage, right? Maybe I want to leverage that for additional virtual machines. Maybe I want to make my environment a little more dense, add in additional virtual machines. So by removing some of the storage from the virtual machines, I can then take advantage of placing more virtual machines in VMC without adding additional hosts. So as you can see here, we're grabbing the same VPC subnet. We're doing Windows authentication with the directory service that we had before, and we'll create our file system. Same thing here. It can take about 40 minutes to deploy. We speed it up to about 10 seconds, so I can talk a little bit as well. And now that's great. So what do we need to do next? Well, we're going to go to our application virtual machines. We'll grab the DNS for our directory service, and we're going to ping that from our one of our application servers. So for us to do this, we go into the application server, we open up command prompt, and we can put in those two private IP addresses of our directory service. Now keep in mind, these are 10.0 IP addresses. Our virtual machine is a 192.168, and this is available because we've allowed the connectivity between the two accounts. So we were able to ping those. So we'll go ahead and we'll update the DNS of these virtual machines to the DNS of the directory servers. So once we do that, we can then take advantage of Active Directory and join these virtual machines to the directory services domain that we created, okay, which is that VMC workshop. So I can go to change here. I'll go to my domain. I'll go back to directory service and show you we are using VMC workshop.local. Okay, we add this in here. And then it's going to ask us for the username and password. So this username is going to be admin, and the password is what we set when we deployed the directory service. So I'll go ahead and add that in, and it should say, hey, things are great. Thank you for joining. Go ahead and restart. So welcome to the domain. We've joined the domain. We'll let this restart, and we'll move on to our second virtual machine. Now, as we do this, a few things to think about. When you're creating this at scale, how do I do it? Because I'm showing you this with just two virtual machines, right? This is something that can be scripted. You can add in a group policy on your virtual machines as well. You can script this out with remote PowerShell. There's a number of different ways that you can enable this and connect these to the domain. So even though I'm doing this in a manual effort during this demo, just keep in mind that if you're doing this at scale, you're not going to want to do this one at a time, right? You're going to want to go ahead and have this scripted. So as we're going through this, once again, we've talked about things like application load balancers, web application firewalls, integrating with EC2 instances, Shield. We've talked about RDS databases with additional availability. We've talked about adding things like QuickSight and big data, Redshift. We're going through all these ones. And in this time that we've gone through and talked about roughly 8 or 9 services, there's over 200 services that AWS has. So what are different things? What are the different business requirements that you would have that you would want to enable or enhance for your customers? Okay. So we're back to our application 1, and we're going to go ahead and log in now with our Active Directory credentials. So we'll go ahead and add in our admin account here. And once we log in, we want to then take some of the files that I have running on this virtual machine and offload them. Let's just get them out of VMware Cloud on AWS. So the first thing we're going to need to do is once we're in here, we're going to want to grab the command or the direction address, I should say, of FSX that will then be used to map a network drive within the virtual machine. So in here, we will we grabbed that. We'll log back in now in the domain. So we've got admin. We'll put in our admin credentials, and then we'll go to our folder explorer and map network drive. So you can do this through the command line. I wanted to show it here as well. So we take the FSX address, Amazon FSX, and then the part that's unique to my account, the VMC workshop, because we tied it into the directory service.local/share. So if we open this up, we've got it attached. Now that's awesome, but we have nothing in it. So normally we'd go ahead and probably have a certain directory structure, but we'll just grab a few files off of the original account on this virtual machine that I had downloaded for some of these demos, and we're just going to throw them in there. So that looks great. But let's make sure that this works, right? Let's make sure that this is actually shared storage. So we'll log in as well, do the same thing here on our second application server, and see first off if we can see those files, and then we'll see if we can add our own. And this can also be good, not just for offloading files, but if you have applications that require shared storage. If you had a shared storage appliance that you had running in vSphere, maybe you want to remove that so that you're not filling up the data store with a file server, and you want to just start to leverage things like FSX or EFS or even S3, depending on the type of technology that's being used. So here in our second application VM, you can see the workload or the files that we had placed there from our first virtual machine. We're going to come back and we'll grab a file from our temp directory here, because in our virtual machines, I actually installed CloudWatch and the SSM agent as well. So we can actually get CloudWatch logs from our virtual machines. This is not part of the demo, but part of the art of the possible, right? So we've got our SSM agent and our CloudWatch agent installed on these virtual machines as well. So not only are they in VMware Cloud on AWS, but I'm able to then push updates to my my virtual machines from the SSM console, as well as get logs from in CloudWatch from these virtual machines. So all that being said, I just spoke nonstop for the last hour. I had a fun time putting these together and going back to the whole, all right, what else can I do? What else is there that I can mix and match, right? That being said, that is it for the demo portion, and we are going into a Q&A. So we have a few minutes left that we can use to do Q&A. I'm going to open this up. Do we have, Eric, do we have any questions that have come through that still need answering?
As of right now there, Brian, no, but feel free to bring up some FAQs for the audience. I'm sure they'd love that.
Okay, awesome. So let's go back to just my face. I can't actually see. I had the Connect. There we go. At Connect closed down on me. So frequently asked questions about this, right? What all can I do? Now, it's kind of a funny question because we've talked about this across the entire length of this session. The question shouldn't be what all can I do with these integrations. The real question should be, what does your customer need, or what do your internal teams need to better help further your cause or the user experience? So as we've worked with partners and other customers, we start to kind of dissect that and go, what is actually needed here? Well, maybe we want to have better insight into what people are clicking on, what people are actually doing. Where do we store all this? Or can we start to bring in data points from all our different databases and run some big data queries on these? Let's find or do some ML on this as well, right? So the question really then becomes, what do you need to help your customers or to grow your customer base, right? Or to keep your customers, and then work backwards from that. The great thing about this is, as you saw, once you open up that connectivity, really, you can do anything. You can leverage pretty much any of the different services and integrate those with VMware Cloud on AWS. Other questions that we get are around cost and availability. So like I said before, when you're leveraging additional AWS services, those are billed to the account that they're running in. So as we saw when I deployed the directory service and FSX and everything else, those are still being billed to me just like they would in a regular AWS account. So that's technically separate from the VMware Cloud on AWS SDDC. So there is a delineation between what is billed to an account that's doing services versus the SDDC itself. Now, anytime that you're creating something, as you are deploying the SDDC for the first time, choosing your availability zone is important. There's one thing that some people don't know, and so you can look up the AZ mapping in your EC2 dashboard in AWS. If you go to your EC2 dashboard in AWS, you'll see the AZ name and you'll see an AZ ID. Okay, the AZ name is a logical name. And so mine in US East 1, let's say I have US East 1A, that is a logical name that may not actually be backed to the same backend as your US East 1A. So as you're looking at trying to minimize cross AZ data charges, when you deploy something between different accounts, right? Take a look and make sure that the IDs match rather than the logical name. And that will not only save cross AZ data charges, but it also, by being in the same availability zone, you have slightly better performance, slightly less latency, right? So there's a few different benefits to making sure that you choose the AZs that you want to use. And Eric, just let me know if any questions come in while I talk here. I'll probably do a couple more FAQs, and then we will turn it back over to you to wrap things up. So another thing to consider here as you are doing this, I talked about it briefly at the end, but I didn't actually have this as a demo. When you move up to the cloud, what are things that you may potentially already be doing in the cloud that you want to have brought over into VMC as well? So in my case, I have added CloudWatch agent and the SSM agent into my my Windows workloads. Now I scripted that using PowerCLI and basically deployed that into each of my virtual machines and configured it so that I could start using the SSM agent. If I want to push patches or push configuration changes, I can do that as well. So all of a sudden, as I get up into the cloud and I'm creating these hybrid applications, the next question is, well, how far can I take this? And the question really is a business question that comes down to each individual business and their business requirements. Do I want to all of a sudden start working on modernizing my applications and immediately putting things into different microservices or into additional technologies that we have in AWS? Or do I want to run like this for the foreseeable future, because I already have my scripts, my run books, and everything else here? Keep in mind that as you start to modernize your applications, you do have the operational side of this as well that you need to make sure is in lockstep with you, so that if there becomes a time where there's an issue with the application or a customer impact, that your run books are up to date on how to handle this when you're in a hybrid environment, rather than just as a virtual machine, because that will be slightly different. So as we talk about the technical side of this, keep in mind that you want to work with your teams within your company to make sure that the other areas of your company are aligned with this, primarily and almost exclusively your operations teams. So make sure that everyone's on the same page. But once again, take a look at what the benefits are of enhancing your applications or adding in technologies and services that you wouldn't have been able to do on-prem.